the chapter triangles. So in the first question, they've given that in figure 6.17, 1 and 2, DE is parallel to BC. We need to find EC in the first question and AD in the second question. And they've given that, in the first question, they've given that DE is parallel to BC. Using the BPT theorem, we can say that the line DE divides the lines AB and AC in equal proportions. So if that is true, then AD by DB is equal to AE by EC, since DE is parallel to BC. And we know the values of AD, DB, and AE, and they're asking us to find EC, so we can substitute those values in here. So AD, which is 1.5 by DB, which is 3, is equal to AE, which is 1, and EC, which we have to figure out. So we can cross multiply this in order to find EC. So we can say that EC 1.5 EC is equal to 3, and EC is equal to 3 divided by 1.5, and 3 divided by 1.5 is equal to 2, so the value of EC is equal to 2. In the second question, DE is parallel to BC, where AD is unknown, and the value of DB is 7.2, the value of AE is 1.8, and EC is 5.4. They're asking us to find AD, and they've given that DE is parallel to BC, and according to the BPT theorem, if DE is parallel to one side of the triangle, then it divides the other two sides in equal ratios. So then AD by DB is equal to AE by EC. Here, we don't know the value of AD, so we're going to keep that as is. So AD by 7.2 is equal to 1.8 by 5.4. 1.8 and 5.4 can be simplified as 1.3. So cross multiplying AD by 7.2 and 1 by 3, we'll get 3AD is equal to 7.2. So AD is equal to 7.2 divided by 3. So the value of AD is equal to 7.2 divided by 3, which is equal to 2.4. In the second question, they've said that E and F are points on the sides of PQ and PR respectively, of a triangle PQR. For each of the following cases, state whether EF is parallel to QR. So in the first question, they've given the values of PE is equal to 3.9, EQ is equal to 3, PF is equal to 3.6, FR is equal to 2.4. In order to prove that EF is equal to QR, we need to prove by BPT that PE by EQ is equal to PF by FR. Because if EF is parallel to QR, then EF divides the two sides of the triangle PQ and PR in equal ratios. So we're going to substitute these values here. So PE, which is 3.9, by EQ, which is 3, needs to be equal to PF, which is 3.6, by FR, which is 2.4. So we know that 3.9 divided by 3 will give us 1.2. And 2.4 and 3.6 can be simplified as so 1.8 divided by 1.2. When we further simplify this, we will get 0.9 by 0.6. Further, we will get 0.3 by 0.2, which is not equal to 1.2. So we can say that EF is not parallel to QR. In the second question, they've given the values of PE is equal to 4, QE is equal to 4.5, PF is equal to 8, and RF is equal to 9. So using the basic proportionality theorem, BPT theorem, we need to prove that PE, which is 4, by EQ, which is 4.5, is equal to PF, which is 8, and FR, which is 9. So first we need to simplify the first. If we prove that this is equal, then we can say that EF is parallel to QR. So the first part of this equation 4 by 4.5 can be written as 4 by 1 by 45 by 10, which can be written as 40 by 45, which can be simplified as 8 by 9. So 8 by 9 is equal to 8 by 9. Hence we can say that EF is parallel to QR. In the third question, they've given that the value of PQ is equal to 1.28, PR is equal to 2.56, and PF is equal to 0.36, and PE is equal to 0.18. So here they've given the values of PQ and PR, and like in the first two questions, they gave the values of PE, PF, EQ, and FR separately. So we need to find the values of PE and EQ by subtracting the values of 1.28 from 0.18 in order to find the values of EQ. Similarly, for the other side, we need to subtract 0.36, which is the value of PF, from PR, which is 2.56, in order to find the value of FR. So first, we can write that EQ is equal to PQ minus PE. So EQ is equal to PQ, which is 1.28, minus PE, which is 0.18. So EQ is equal to 1.1. Similarly, we can write that FR is equal to PR minus PF. So FR is equal to PR, which is 2.56, minus PF, which is 0.36. So FR is equal to 2.2. So now that we know the values of FR and EQ, we can now write it in their respective ratios. So in order to prove that EF is parallel to QR, we need to prove that PE by EQ is equal to PF by FR. Here the values of PE is equal to 0.18. The values of EQ, which we found, is 1.1. Similarly, PF is equal to 0.36, and the value of FR is equal to 2.2. So now we can write these simplified as 18 divided by 100 by 11 divided by 10, which is equal to 36 divided by 100 by 22 divided by 10. So when we bring it over to the first fraction, we will get 180 by 1100 is equal to 360 divided by 2200. So zeros and zeros will get cancelled. So 18 by 110 can be simplified as 9 by 55. Similarly, 36 by 220 can be written as 9 by 55. So since both of them are equal, we can say that EF is parallel to QR. In the third question, they've given that in the figure, if LM is parallel to CB and LN is parallel to CD, we need to prove that AM by AB is equal to AN by AD. So first they've given that LM is parallel to CB. So this is LM and this is CB. So we will notice that ABC form a triangle. So we can write that firstly, in triangle ABC, LM is parallel to BC. Since LM is parallel to one side of the triangle BC, then LM divides the other two sides in equal ratios. So we can say that AM by MB is equal to AL by LC. Similarly, in the second triangle, they've given that LN is parallel to CD, LN, CD. So we will notice that in triangle ADC, LN is parallel to DC. And if LN is parallel to one side of the triangle DC, then it divides the other two sides in equal ratios. So we can write that AL by LC is equal to AN by ND. So in the question they're asking us to prove AM by AB is equal to AN by AD. And we will notice that in both of these equations that we have arrived from the given information, that AM by MB, which is given in what we have to prove, AM by AB, which is equal to AN by AD. So we will notice that the first AM and AN is here, but in the denominator it's AB and AD. But however, both of these equations is equal to AL by LC and AL by LC. So that means we can equate AM by MB is equal to AN by ND. So we can write AM by MB is equal to AN by ND. And now that we've written this, they're asking us to prove that AM by AB is equal to AN by AD. So we're going to reverse the order. So basically we're going to cross multiply. So we will get AM times ND is equal to AN by times MB. So we will get, so now we're going to bring AM over and divide it by MB and AN divided by DN divided by AN. So we're going to rewrite this as ND divided by AN because we're bringing it over to the left hand side, and MB divided by AM. So you might be wondering why we have done this and changed the order, but this is because in the question they're asking us to prove AM by AB is equal to AN by AD. And here the values of AM and AN remain the same. However, in order to arrive at AB and AD, we're going to have to add 1 to both sides of the equation. And when we add 1 in the first scenario, AM will be AM plus 1, so AM plus MB will give us AB. But we need to have AM in our equation. So we're going to reverse it so that we have to add MB plus AM, and we'll have AM in the denominator, so that we'll still retain the values of AM and AN in the final answer. So as I said, we're going to add 1 to both sides of the equation. So when we do so, we will get ND plus AN divided by AN, which is equal to MB plus AM divided by AM. So now you'll notice that the values of AN and AM do not change, but we add the values of AN to the numerator. So that will add up to AB. So ND plus AN, which is ND plus AN, will give us AD by AN, and MB plus AM will give us AB by AM. In the question, they're asked us to prove AM divided by AB. And in the second part, they're asking us to prove AN divided by AD. So we're going to have to reverse the order again. So we can rewrite this as AN divided by AD, which is equal to AM divided by AB. In the fourth question, they've given that in the figure, DE is parallel to AC and DF is parallel to AE. We need to prove that BF by FE is equal to BE by EC. So first they've given that DE is parallel to AC. So DE is parallel to AC. So in the triangle ABC, the line DE is parallel to AC. Since DE is parallel to one side of the triangle AC, then we can say that BD by AD is equal to BE by EC. Similarly, in the second part, they've given that DF is parallel to AE. So DF is parallel to AE. So in triangle ABE, the line DF is parallel to AE. So we can write BD DF is parallel to AE. So we can write that BD by AD is equal to BF by FE. So we will notice that in both of the equations that we have arrived at, BD by AD is similar in both of the equations. So that means we can equate BE by EC is equal to BF by FE. Hence proved. In question number 5, they've given that in figure DE is parallel to EQ and DF is parallel to OR. And we need to prove that EF is parallel to QR. So they've given that DE is parallel to OQ and DF is parallel to OR. So both of these are given, and we need to prove that EF is parallel to QR. And if EF is parallel to QR, then we can also say that PE by EQ is also equal to PF by FR, because if EF is parallel to QR, then it divides the other two sides of the triangle in equal ratios. So we need to essentially prove this in order to prove that EF is parallel to QR. So first they've given that DE is parallel to OQ. So DE, which is this line over here, is parallel to OQ, which is here. So in triangle PQO, the line ED is parallel to QO. So since ED is parallel to OQ, then we can say that PE by EQ is equal to PD by DO. Similarly, in triangle POR, they've given that the line DF is parallel to QR. DF is parallel to OR. So since DF is parallel to OR, then we can say that PD by DO is equal to PF by FR. And we will notice that in both of the equations, PD by DO is the same in both of the equations. So that means we can equate PE by EQ is equal to PF by FR. And this is exactly what they've asked us to prove in the question. PE by EQ is equal to PF by FR. Hence proved. In the sixth question, they've given that in figure ABC are points on OP, OQ, and OR respectively, such that AB is parallel to PQ and AC is parallel to PR. We need to prove that BC is parallel to QR. And if BC is parallel to QR, we know that its respective sides in the triangle will get divided into equal ratios. So that means OB by BQ will be equal to OC by CR. So we need to prove this in order to prove that BC is parallel to QR. So first they've given that AB is parallel to PQ. So AB is this line and PQ is this line. So in triangle OPQ, they've given that AB is parallel to PQ. And since AB is parallel to PQ, then its respective sides of the other two sides of the triangle will get divided in the same ratio. So that means OA by AP is equal to OB by BQ. Similarly, they've given that AC is parallel to PR. So AC is parallel to PR. So in triangle OPR, they've given that AC is parallel to PR. And if AC is parallel to PR, then we can say that OA by AP is equal to OC by CR. And we will notice that in the two of the equations that we have arrived, that OA by AP is the same in both of the equations. So that means we can equate OB by BQ and OC by CR. So we can say that OB by BQ is equal to OC by CR. And since this is equal, we can say that we can prove that BC is parallel to QR, because when BC is parallel to QR, then OB by BQ will be equal to OC by CR. In the 7th question, they've given that using the basic proportionality theorem, we need to prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. So let us assume that D is a midpoint on the side AB. So if it is a midpoint, that means it divides the line into two equal parts. So that means DA is equal to DB. And they've also given that DE is parallel to BC. And if DE is parallel to BC, then we can say that AD by DB is equal to AE by EC. And they've asked us to prove that it also bisects the midpoint of the other side. So we already know that AD is equal to DB. And if AD is equal to DB, that means AD by DB will equal to 1. So 1 is equal to AE by EC. And if we bring EC on the denominator on the right hand side to the left hand side, it'll become multiplication. So we can say that EC is equal to AE. And this is what they're asking us to prove. We need to prove that a line drawn through the midpoints of one side of a triangle parallel to another side bisects the third side. And if EC is equal to AE, that means the line DE bisects the line AC. Hence proved. In the 8th question, they've given that using the converse of basic proportionality theorem, we need to prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So, they're asking us to prove that DE is parallel to BC. And they've given that DE is the line that bisects the two sides AB and AC. Since D is the midpoint on the line AB, then we can say that AD is equal to DB. Similarly, if E is a midpoint on the line AC, then we can say that AE is equal to EC. So if we divide AD by DB, we will get 1. Similarly, if we divide AE by EC, we will get 1. So since both of them are equal to 1, we can say that AD by DB is equal to AE by EC. And in order to prove that that a line is parallel to another side, we know that by the basic proportionality theorem, that means the other two sides of the triangle will get divided in an equal ratio. And since we've proved that AD by DB is equal to AE by EC, proving that the two sides are divided in an equal ratio, we can say that DE is parallel to BC. In the 9th question, they've said that ABCD is a trapezium in which AB is parallel to DC, and its diagonals intersect each other at point O. We need to prove that AO by BO is equal to CO by DO. So, we're going to draw a line EO in the triangle ADC. And they're asking us to prove AO by BO is equal to CO by DO. And we're going to draw EO such that EO is parallel to DC and it's also parallel to AB. So we're going to draw EO such that EO is parallel to DC and is also parallel to AB. So in triangle ADC, we have EO is parallel to DC. And if EO is parallel to DC, we know that AE by ED is equal to AO by OC. And they're also asking us to prove that AO by BO is equal to CO by DO. And next, in triangle ADB, EO is parallel to AB. So in triangle ADB, EO is parallel to AB. And since EO is parallel to AB, that means ED by EA is equal to DO by OB. Here we will notice that AE by ED and ED by EA are in both of the equations. We just need to rewrite it so that it's in the same order. So EA by ED is equal to OB by OD. So that means we can equate AO by OC and OB by OD. So we can write AO by OC is equal to OB by OD. And they're asking us to prove AO by BO is equal to CO by DO. And in order to get at the answer that they're trying to get us to prove, we just need to rearrange it by cross multiplying. So we can bring OB over to the side, OC over to the top. So we will get AO by BO is equal to OC by OD. Hence proved. In the 10th question, they've given that the diagonals of a quadrilateral ABCD intersect each other at points O, such that AO by BO is equal to CO by DO. We need to prove that ABCD is a trapezium. So, in order to prove that ABCD is a trapezium, we need to prove that DC is parallel to AB. The opposite sides of a trapezium are parallel, so we need to prove that. So as we did in the previous question, we're going to draw line EO, which is parallel to AB and DC. So we can say that EO is parallel to DC and is parallel to AB. And in triangle DAB, since EO is parallel to AB, that means DE by EA is equal to DO by OB. And in the question, they've given that AO by OB is equal to CO by DO. So they've also given that AO by BO is equal to CO by DO. And here they've given DO by OB. So we're going to rewrite it so that AO by OC is equal to BO by OD. So now we're going to arrange it so that OD is on top. So we will get OC by AO is equal to OD by OB. So this will be the second equation. So from this first and second equation, OD by OB and OD by OB are similar in both the equations. So that means we can equate DE by EA, which is equal to OC by AO. So if DE by EA is equal to OC by AO, that means EO is parallel to DC. So they've given that DE by EA is equal to OC by AO. So that means the sides are divided in equal ratio, and since EO, that means we can say that EO is parallel to DC. And since EO is parallel to DC, and we have already assumed that EO is parallel to AB, that means DC is parallel to AB. Hence proved.